Good morning, all. Myself, K. Balakrishna, Assistant Professor of CS and SL University. Now I am discussing the topic of stack using linked list from data structures. In my previous class, just I'm completing my stack using array concept. Today, just I am discussing about stack using linked list. Okay. So for here, first just I'm giving the brief of what is meant by stack. Later we'll move into linked list. So first the stack is only one way insertion and deletion possible with this one. So this is it contains only single L. Okay. So this one is calling it as a here always insertion and deletion from top element. Okay, if I'm trying to insert the data here, then 20, 30, 40, 50, so on. So this is so here index is 0, 1, 2, 3, 4. Okay. Here this is so always top should be initialized with -1. Always it will be incrementing. The top is moving from -1 to z +1, later +1, later +1, later +1, later +1. So my top is now in pointed to the 50 error. Clear. So main motto of the stack is last input first out or first input last output. So this stack is mainly using so recent data storing as well as undo operations. Clear. So this is regarding this is my stack and this is the representation of stack using array. Okay. Next is if I'm discussing about if I'm going with linker list. What is the representation? Just with Saki. Okay. Again, this is my stack. This has only single hand, that is this one. So always all operations should be done at from the top only. Here just we need to insert the nodes into my list. Here. So this one is one node, this one is one node, this one is one node, and this one is one. Okay. The node contains always two parts. One is data part, second one is next node address. Okay, here again we are taking the top is here. So instead of -1, just here I am going with none. There is no address for the top initially. Clear? So here just okay. So if I'm trying to create the first node, that is called new node. Okay, just I'm trying to create one new node. Okay, new node is equal to some 1000 address. Okay, the node contains two parts. Okay, here this one is occupies 1000 memory. Here it has two parts. One is data part, second one is address part. In the data part, I need to take the data as 10. In next part should be none. So all of you know how to create the node. So just I'm trying to write the logic for that. New node is equal and log size of struct node. So all of you know the syntax for allocating memory. So it should be written the pointer only. That's why I'm going with struct node point. Here it will be created one node here. Okay. Okay. So how it will be created? It should be created one node that should be here. It has some memory location. So in that just I need to read the data. So for that I need to write scanf scanf percentile t comma new node data part. Okay. So before that, just we saw how to create the single linked list nodes. So for that, I'm taking it contains two parts only. Struct node. Now in the just we have int data part. Next as single node. That's why we are taking only single pointer address, that is only next address. So just here we need to take. So after that, struct node, I need to get new node is equal null, comma, top is equal to null. Till now, just we are utilizing these two. Okay. So this one is done. Till now, the data is reading now. So immediately what I need to do, very first case, new node, next should be null. Okay. So what I'm doing here, just we need to place the null here. So very first case, okay. So before that, just we need to check what we need to check here, whether the stack is full or not. If the stack is full, there is no elements pushing. Okay, with the help of linked list, there is no full, but we need to check whether the memory is allocated or not. If new node is null, new node is null. Just we need to write printf memory not allocated. Clear? Yeah, after that, just we need to read this one. Okay. So what we need to do here, just we need to write here again. If, sorry, just we need to write here one more statement. After that, printf enter data to no. Scan. This one is done. Okay. So what we need to do, just till now, just we are taking here, just taking the data as well as insert the data into the node. Next one is the next part is also null here. This is also done till now. So next what we need to do. So if it is single node, there is no problem. So if it is yeah, what next thing what we need to do here, the top is null. My top is pointed to here. So further just here, I'm trying to maintain one top here. So like one pointer. Okay, very first case it is null. So then what I need to do, the null is replacing with here. Yes, the null is replacing with 1000. Clear. So then it should be pointed to here. The 1000 is pointed to this node. Clear now. So if the data is empty, if the data is empty, then we need to write the null. So if data is existing, then what we need to do here? What we need to do? Just we need to place the data. Okay. So top next is equal to null, very first case. Okay. New node data. So this should be placing in else part here. No problem. Else. Just here, we need to replace new node next is no next is null. So this one is replacing with for next case, just with new node next is equal top. So if I'm trying to create one more node here, just that is 20 here. Okay. Okay. So very first case, this is empty. Okay, very first case, this is empty. Okay, just I need to point. I need to establish from this to this. So what is this has top? Top has 1000. the 1000 should be here. Okay. So here, this memory is 2000 again. This one is other node. If I'm coming to here, this one is 30. Okay, 30 storing has 2000. So again, just we need to establish the link from here to here. Okay, this memory is also, this memory also 3000. Okay, the 3000 should be popping here. 40 is here. So again, the link is establishing here. Okay. In second case, the top is earlier 1000. Okay. The 1000 should be replacing with 2000. Next case, then, so the pointer should be the top is pointed to next case. Here, in third case, the top should be replacing with 3000. Okay. Now the top is moving to here. So next, here the top is replacing with 3000 is replacing with 4000. So now it is pointed to here. So now so here the data is pen. The first node is null. Okay, this one has 1000. This memory has 2000. Clear. So now the top is pointed to here, but now the top is pointed to the last three. So this is 4000 address. Okay, that is the top. The top element is 40. Okay, so for that, just what I need to do here, very next case immediately, top is equal new node. So each and every time the new node, the top will be, the top address will be moving. First case, the top is here, 1000. Second case, top is 2000. Third case, sorry, new node is 1000. The 1000 should be assigned to top here with the help of new node. So next, the 2000 should be assigned to here, 3000 should be assigned to here, 4000 should be assigned to here. But till now we have 4 nodes, so that's why we are assigning one by one. Clear. So next thing, if we are going with parameterized method, so this is step node. So here I am taking one method, that is push, void push. In a value something here. Just this in this method. What we need to write here? Just I'm trying to removing these two lines. Just I'm trying to write new node data is equal to value. Why? Because we are taking parameter. Okay, new node next is equal top. So very first case, if I'm applying for this one, new node data. So first node, new node data is 10. New node next is equal to top. What is the new node next? Top. New node next is the address. What is the top value? Initially top is, so top is null. Then here new node next also null. So this is the case satisfied, very first case. So next, top is equal to new node. Top is equal to new node. What is the new node here? So new node address is 1000. That should be allocating here. Okay. First, new node is equal to 1000. That should be assigned to top. Okay, here the null is replacing with 1000. Okay, if I'm trying to calling again this method. So earlier the 1000 is existed here. 10 is completed. Now here the 10 is replacing with 20 here. Okay. Here the next is null is replacing with, here top is 1000. Okay. Here null is replacing with 1000. Okay. New node is 2000. Again top is also 2000. So next 30, next 40, so on. So in this way, just we need to push the data into stack using linked list. Clear. So next, how to removing the data? So for that we have void pop. How to remove the data? So always insertion as well as deletion should be done at single end, that is top. So with the help of top only we need to remove. So what the top is pointed to here, 4000. Okay. So here just we need to write here top is equal 4000. Okay. 4000. 4000 data is okay. So what I need to do here, just I need to take one temporary here, one temporary node. So for that here I'm taking one temporary node. Is it very initial? That is equal to top. So now here just what I need to do here, temp is equal to top initial. What is the top value? 4000. The 4000 should be copying here. Okay, 4000 should be copying here. So it should be pointed to the top node. Okay, now the top is pointed to here as well as the temporary also pointed to here. Clear. Shall I write top is equal top next here? Shall I modify here text? Top is equal top next. So here, what is the top here? 4000. What is the 4000 next? 3000. Right. Now the value is top is equal to what should be assigned? 4000 next pot. What is the next pot here? 4000 next is 3000. So the 3000 should be top is equal to 3000. Okay. Yes. Rest. What I need to do here? I need to remove this pointer from here to just now it should be the 4000 is replacing with 3000. The 3000 node is pointed to here. Clear. Just we need to vanish this. So now this one is 4,000 is replacing with 3,000. Okay, this is done. So now it is here. Okay, but even the temporary is pointed to here. Just I need to remove this memory location. For that, just I need to write here one more statement. What is the statement here? Free of temporary. Okay, just if we need to write this one, the memory should be deallocating free of this memory. Okay, again we have temp is equal to top. What is the temporary value? See, earlier it is not top. What is the top is here? 3,000. The 3,000 should be assigned to here. So this one is removing and it should be replacing with 3,000. Okay, next it should be pointed to the 3,000 node. Okay, this relation should be destroying. This one should be destroying. Clear. So just I need to write the logic for this one here. So for that, first of all, I need to take one pointer help. Struct node state temporary. Clear. Okay. First, I need to check if top is null. So if it is empty, there is no possibility of deletion. So printf stack is underflow or empty. Stack is empty or underflow. So deletion is not possible or popping is not possible. Clear. Else what we need to do here? Else directly we can write temp is equal top. Next printf pop element is percentile D, comma. What is this one? Temp data or top data. Okay. Yes, we are going with here top data. So you can write temp data also, no problem. Why? Because the temp is assigned with top. Clear. So next, what we need to do here? Top is equal top. Next free of temporary. So just in this way, we need to pop the data from the stack using linked list. Clear? These two are done. Okay. Next, we need to display all the elements. Okay. For that, we have one more function. That is void display. So again, we need to check whether it is empty or not. Here also, I'm taking one temporary help. Why? Because we need to move from each and every time. Okay. 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 First we need to print the 40. Okay, my top is pointed to 4000. Very first case. Clear. Okay, just I should be vanish this one. Yes. Okay. Okay. This is my stack. Okay, this one is one more. This one is one more. This one is one more. Okay. My top is pointed to here. So from this only, we need to print the data. Okay. So up to this last node next is none. Clear. Until we need to display. If it is empty, there is no display is there. Okay. Okay, just I need to write here temp is equal top. Why? Because here why I'm taking the help of temporary here. So always top is pointed to first one. Okay, top is not moving to next one. So we need to display all the elements irrespective of your top. So here if it is the data is here 1, 2, 3. Okay, I need to display here 3, 2, 1. Further, the top is pointed to only single node. So with the help of top, I did not move to the next node as well as the next node until end of the list. So for that, I need to take the help of temporary. Okay, the top is assigned to the temporary here. Okay, so very first case here, what will happen? So if this one has 3000 memory, this has 2000 memory, this has 1000 memory addresses. Okay, so here I am taking two nodes here. Okay, so that is here I'm taking. If this one is temp, this one is top. Okay, top is already existed with 3000. Okay, so temp is equal top. So the top also temp also is 3000. So both should be pointed to same node. Yes, obviously this one is a S1 as well as this one also. This, but the top is not moving from here. If the top is, I need to move my top from here to here. Just I need to remove the first element. That is the address of 3000 memory location. Okay, for avoiding that, I'm taking the take help of temporary. So I need to move from here to here, from here to here. Okay, just accordingly we need to display. So for that, this is a repetitive process here to here, here to here. So just I'm traveling like this while temps not equal to null. What it means? Temp not equal null in the sense the last node address is 1000 memory. So first case, this has 3000. So next case, this has 2000. In next case, this has 1000. Okay. Next last case, it has empty. That is null. So for that temp not equal to null. So our data is present up to not equal. 1000 has some data, 2000 has some data, 3000 has some data. That's why I'm not consideration of null. Okay, just what we need to do, I need to move my temporary width is equal temp next. Okay. Okay. Here moving is properly. But what is my intention? My intention is I need to display all the data which are present in your stack. Okay. All the nodes of data. So further, just I need to display very first case 3000 is pointed to here. I need to display the 3000 data. For that, I am trying to write printf percentile d slash n comma temp data. What is the temporary? What is the temporary? Temporary is the very first case 3000. What is the 3000 data? 3. 3 should be printed here. Later, the temp is moving to next. Temp to next. What is the temporary? 3000. What is the 3000 next? Obviously, it contains 2000. So it should be moving to here until it reaches to null clear. So in this way, just we need to display all the data which are present in your stack. Clear? So just we need to write the logic, complete logic for this and execute this code. How it will be. Let's we check here. So very first case in previous examples. Yes, here just we are going with. Here. So here the top is pointed to 3000. Now here top is equal to temp is equal to top is equal 3000. Very first case. Okay. Next. 3000 is not equal to null, obviously. Then print the data. So what is the data? 3000 data, that is 30 is printing here. Next case, temp earlier is 3000. Okay, 3000 is equal temp next 3000 next. What is the 3000 next? 2000. Okay, here the 3000 is replacing with 2000. Clear. Okay. So here the 3000 should be replacing with 2000. Now again it will check for 2000. 2000 is not equal to null. Yes, obviously. Coming to here, it will be print next 2000 data, that is 20. Okay. Next 2000, here 2000 next. What is the 2000 next? 1000. Okay. Here the 2000 is replacing with 1000. Again, it will be 1000 not equal to null. Yes, obviously. So coming to here, the 1000 data, that is 10, which is also printing here. Okay, 1000 is already is here. 1000 next. 1000 next. What is the 1000 next? Null. Okay, the 1000 is replacing with null only. So in this case, just where null not equal to null, as it is false, then it will be skipping from here to Clear? Just in this way, your display part will be executed. Clear? So next, I'm trying to write the main method for this. Okay. Test main. Test. I'm trying to take one int value, comma, option, printf, enter option. So before that, for the test, we need to write one for push slash n, two for pop slash n, okay, three for display. Sorry, you may go with peak element also. Three for peak slash n, four for display slash n. Okay. Next, printf, enter your option. Scanf percentage d, comma, ampersand op option. Clear. So this should be in while. It is a repetition. So while one always true. So this should be placed in here. So before that, just what we need to do here, find while peak. Just we need to check whether if it is empty, there is no elements present in the stack. Else, just we need to printf peak element is percentile d slash n, comma, top data. Top element data. Okay, this one is also done. Next, option y. Okay, next. Next, I'm taking here switch case. Switch option is parameter. Next, case one, printf, enter data to stack. Scanf percentile b, comma, ampersand flat. Okay. Next, what we need to do? Just we need to call push off val. Clear? Next, break. Next case two, pop, break. Case three, peak, break. Case four, display, break. Case five, HC, break, default. Okay. Invalid option. So after that switch is done. Next, file also done here. Yes, we need to save the file. Tag using linker list dot c. Removing here. So we need to add two statements as include stdio dot h. Stdio dot h. Printf. Yeah, there is no need to take the size 1, 10, 1, 20, 1, 30, 1, 40, 1, 50. Rest option is for 10, 20, 30, 40 is there. So peak element 50 is also there. Two popped element is 50. Two popped element is 40. Two popped element is 30. Two popped element is 20. Two stack is empty. Clear. If I'm trying to take display, stack is empty. If I'm trying to go in with peak element, stack is and option 1. Right. If here 2, stack is empty. Next 4, stack is empty. Clear. Just in this way, just we need to execute the stack using linked list. Okay. Thank you for watching.